Talk like you would talk.
Hi. I'm going to talk like I would talk.
Okay.
This is usually how I talk.
All right, that's fine.
Okay, good.
I was just making sure it wasn't like going to blow my eardrums out.
Oh, yeah. All right, then. That's fair. Okay. Hey, and welcome back to another episode of the Cables to Clouds podcast. I'm Tim, and with me as usual is Chris. And we're going to try something a little bit different. People have been asking for a while for us to kind of get into some of the basics of cloud networking. Obviously we have a lot of listeners that are network engineers that are trying to learn cloud, or maybe they just have to deal with cloud, whether they want to learn it or not. And honestly, to be completely clear, we messed around with this a little bit when we first launched, but we couldn't seem to get the cadence right, or it was just really boring. So we kind of shelved it for a long time, but we're gonna give it another try. We kind of thought about it, and we're gonna give it a shot. So today we're gonna talk about VPCs and VNets and VCNs and just kind of the containers that clouds use to build, so that customers can build their cloud networks. We're not going to get super deep. We're not going to get super high level either. We're really going to just talk about kind of design philosophies that all the different cloud providers use for how they're going to build, allow customers to build networks within their platforms. Because at the end of the day, a CSP is the same as an MSP. It's all managed services, right? And so the question is then, for a managed service, when you want to build a network using a managed service, what tools, what did the provider give you to be able to build with? And that's what we're going to get into today, is just starting with, again, with VPC for like AWS and GCP call them, or Google Cloud calls it, VPC. Azure calls it VNet, and then of course, OCI calls it VCN, and I think that's all of them. I can't think of it. I don't know any other ones, Chris. I think that's it, right?
None that matter. We're only
none that matter.
There's only so many we can talk about, so we'll stick with that.
Yeah. Okay. Fair. So let's just get into it, and let's talk about. So basically, let's define what that is, right? So anybody who creates, whether it be an infrastructure as a service type of service where you're creating VM workloads, or you're just creating some location to put data, whatever that is. When you're creating or consuming services from a cloud provider, you're creating, at some point, you're going to have to create a VPC. I'm just going to say VPC, but we're talking about VPCs, VNets, and VCNs, right? I just don't want to say all three all the time as we go through this. It's going to get really old really fast. So I'll just say VPC. You can't even
use an acronym to describe, because it would just be all V's.
It would just be VVVs.
Yeah.
The triple Vs, guys.
Yeah,
when you're making the triple Vs. So that's, again, the basic idea is that it's a container. A container for whatever you're going to build in the cloud. Now, some services are serverless, meaning that you don't actually create and hold on to a particular piece of infrastructure, like Lambda, AWS Lambda, or Azure. It's not Bicep. Hold on, save me, because I can't remember the name for functions. Azure Functions. So yeah, just code that you kind of generate and then the code does something and there's an outcome. You don't need a VNet or VPC for that necessarily, right? So it's really focused on you needing to build some sort of infrastructure or some holding pattern for something that you're going to do inside your own cloud network. So yeah.
There's a lot of times I feel like when you're first learning cloud, there's a lot of similarities drawn between a VPC or a virtual private cloud is your instance of a data center in the cloud, and like we'll get into this a little bit later, but in some scenarios I like that analogy, but in some that I don't, because I think of a data center as a very like broad, like all-encompassing thing, like everything is in a data center, whereas we'll get into this a little bit later, maybe in Google you do have one of those and it contains everything, whereas AWS you might pick it apart and compartmentalize it, etc. So a virtual data center is probably the closest thing, but it can be something as small as just one network, one small subset of the data center, right? So I think that's important to remember when you're kind of designing these out.
Yeah. I mean, and in the book that I wrote for network engineers a few years ago now, I think I specifically said you can think of it more like a network with a router connected to it, and all of the resources that would be connected to that router is fairly close. Now, sometimes that would be like a full data center, depending on how the size of the data center, or, sometimes that's just a piece of a data center. So these are, good explanation in both cases. So let's talk a little bit about kind of that shift from traditional networking into the cloud network piece. And I think for me, the biggest one is this idea of virtualizing the network, right? We know we've used virtual networks to some degree if we have any experience with like ACI or like Cisco ACI or what is the one that Juniper has? Oh my God. Apstra. Sorry. Yeah. Like my brain's not working today, man. Or even like VMware, if we're talking about like VNets and all of that with virtual networking inside a VMware environment, right? But even then, all of those virtualized infrastructure things fail to reach the level of abstraction that the cloud service providers, put you at, because again, it's a managed service, right? So the idea of a hyperplane, where the hyperplane is this gigantic automation system that's orchestrating entire data, not 1, 2, 3, but hundreds of racks and data centers together, right?
Yeah, it's, because all the cloud providers, I think, we've probably talked about this at some point, have introduced this idea of availability zones or AZs. And, under the hood, an AZ is essentially multiple data centers that are, have different levels of fault tolerance and are not, dependent on each other. Whereas if you, as a customer, went to build that yourself, like if you had a regional deployment of something, you want it to be across 3 different data centers, that's a 1 to 2 year project on its own, right? Like that's takes a long time to design something like that. Whereas in the cloud, you do have the option to basically just be like, oh, well, in this region, let's put these 3 things in 3 different data centers. Now that does have its drawbacks, and there's still complexity at the end of the day, which you end up paying for. But it's like you said, it's a mindset shift.
Yeah, for sure. So each provider kind of redesigned or reimagined cloud networking from scratch when they were building their provider services, right? So let's kind of get into that a little bit, and it's going to feel very kind of high level, but I hope if any of you have been using or playing with the clouds, it'll start to make sense, or if not, it'll at least give you an idea of what to expect when you go into any one of these clouds. And again, this is more like their design philosophy of how they make their cloud networking, or not just networking, right? But for our purposes, cloud networking, but really just the whole infrastructure available to you, right? So you have kind of so AWS was first, obviously. AWS was first, and they have both first mover advantage and a little bit of the, what would you call it? Not tech debt, but like, everybody else got to see what was good and what was bad with what AWS did, and then decide if they wanted to do it differently. You know what I mean? Yeah. So AWS kind of has this virtualized familiar concepts, right? Familiar concepts of networking that have been virtualized, right? So we were talking about AZs, or availability zones, which are 1 or more discrete data centers. In AWS, when you build a VPC, that container lives within a region, and by region, we're talking about a true geographic region, but also a logical grouping of data centers, of AZs, that AWS uses. So as an example, the biggest one and the first one was Actually, I don't know if it's the biggest anymore, but certainly the most important to AWS is still US East 1, right? The Northern Virginia. I think it's still probably the biggest, right? So again, within US East 1, we have multiple AZs, and then all together, the geographical grouping of all these AZs make up the region that is US East 1. So from AWS's perspective, a VPC exists within a region. So if I create a VPC that hyperplane object, if you will, exists within every data center that is inside of US East 1, right?
By default. You don't have to explicitly define that. And I think I think when AWS declares a region, it's at least 3 data centers typically.
I think so.
But the US East 1, for example, goes up to 6. So it obviously has a higher level of redundancy. But like we said, that's just by default, and you get to pick and choose how much you want to actually utilize that. And the other cloud providers do the exact same thing, right? Everything is all these AZs or specific data centers are tied to that specific region as a whole.
That's right. Although what's fun, well, as we talk about each provider, you'll see how they chose to, even though they all have that idea of like, hey, here's an AZ and here's a region, they chose to use that differently when it came time to doing the infrastructure for it. So in this case of AWS, let's just start there, right? AWS ties, each subnet is tied to an availability zone. So that's an explicit choice that you make when you create a subnet. So
So maybe just to take a quick step back is like when you define this logical container, this network container per cloud provider, doesn't matter what it is, you basically assign a CIDR range.
Yeah, that's right.
Moving to cloud was the weirdest thing. We started saying CIDR instead of subnet. I don't know why this happened, but like CIDR was the way to describe a network. But you basically assign a CIDR range, which is a supernet that's assigned to the entire VPC or the entire virtual networking construct. And then you kind of chop that up into separate subnets, right? And like Tim is saying, every time you chop that up and you put a subnet into a VPC, you have to define what data center does this belong to, or what availability zone does this belong to.
In AWS specifically. That's a good point. I forgot to mention the CIDR piece. So it's a subnet is just like a subnet. That hasn't changed, right? What's changed with the cloud piece is that, again, we're starting with a supernet, and that supernet exists within the within the VPC, but not outside of the VPCs. That's the whole construct piece, right? And we're going to not talk a lot about how each VPC can actually have the same CIDR, which causes all sorts of network design problems down the road. But
long story short, don't do that.
Yeah, try not to do that. Because but that was a design choice that I think all of them made, really, except for Google ultimately. Was that they were thinking to begin with that an entire enterprise would only ever need one. So they're like, oh, well, just give yourself a /16 network and just go to town. But what ended up happening, of course, is that there were administrative or security or other, for logical reasons to break this up, at least in AWS. The way that AWS designed their constructs made it easier to do design by breaking it up. And what ended up happening is that, then you get into weird things like that. But let's get back to it. So subnets are assigned to AZs, and that's an explicit choice that you make in AWS. But you want to tell us how they did that differently in Azure? So Microsoft chose to do this a little bit differently.
Yeah, so Azure still has the same concept, right? All the regional data centers are divided into specific availability zones, but by default, any subnet that you define within Azure spans all of those data centers. It spans across all of the available AZs, right? So whereas if you think about logically where you put resources in that virtual container, right? In AWS, when you put, virtual machines, essentially the infrastructure that's running in there, a virtual machine is always going to be tied to an AZ. That means it's always going to belong to a subnet that is tied to that same AZ, and everything is kind of locked in this kind of vertical pattern, right? Whereas Azure is horizontal, right? You could have virtual machines deployed in separate subnets, but they're all within the same availability zone. And we won't get too far into it, but like this kind of led to them also developing something called availability sets, where you like, because you have this nature of being able to span across multiple AZs, you have to define, where in those, what logically between those virtual machines is kind of fate shared, I guess is the word I'll use there.
No, that's right, fate sharing.
So you have to, kind of go to extra lengths to make sure that you're making sure that those things are consistently available, with maintenance and things like that. But that is a fundamental differentiator between AWS and Azure. And it can, if you're from one person moving to the other, it kind of like changes the way that you have to think about it, right?
Yeah, and especially how you have to think about how you deploy your infrastructure, right? So in AWS, because you're very explicit about this subnet is going to be assigned to this availability zone, think about from a resiliency design standpoint, like what that means, right? So you're going to deploy essentially like an A side and a B side, like we would, like a red green, like we would think, a red blue rather, like we would think in that makes it very logical. So what I find is that most network engineers find that AWS is very logical to them, like just coming straight from network engineering to AWS, it seems very logical because of things like that, right? People, as network engineers, we think in resilience a very large amount, and the idea of explicit resilience is very, very normal for us as engineers to be thinking about, right? Versus where Microsoft, like Chris said, Microsoft took this idea that like, hey, it doesn't matter where you deploy it because we have it everywhere, and if there is a failure in any of these availability zones, we're going to move your virtual machines for you to another availability zone, right?
Yeah, AWS fundamentally is, a lot of people compare it to Legos, right? It's always that we always give you the building blocks and you can do whatever you want with those. Like we give you that flexibility. Whereas Azure does kind of be like, oh, well, yeah, you can explicitly put stuff in certain, configurations that will align to what exactly you want, but let us handle a lot of that stuff, right? So it's, and then there's default behaviors that drastically change things. So you got to be very aware of those.
Yeah, absolutely. And then, so let's talk about Google Cloud as well, because Google Cloud completely throws the book out in terms of how anybody designed this, right? So with Google Cloud, their idea was, let's create one global VPC for customers, and that global VPC, and it's not that you can only have one VPC, but when I say global VPC, what I'm talking about is a true geographically global construct. Like, not remember I said all the other providers do region locking for a VPC, VNet, whatever. Google Cloud chose to make their construct global. And then when you assign subnets, your subnets are actually associated with different regions, like global regions of the world, basically. So
yeah, so they took the idea kind of the same way Azure does, where the subnet can be span across multiple AZs within the region, but those, whenever you cross regions, those things were always in different virtual networks from an Azure perspective, whereas Google's like, no, everything's in the same VPC. So it's like, it can kind of obviously dictate how you need to facilitate routing and firewalling and things like that between these things. So yeah, it's just another thing to be considerate of. It's like this expanding bubble of what the VPC can contain across the three major providers.
Yeah, and again, what you should be doing as you listen to this, if you knew it, cool. If you didn't know, cool. As you're hearing though about different ways that the cloud providers are providing the same service, basically, because I mean, at the end of the day, a VPC is a VPC is a VPC, VNet, whatever. It's a logical and construct for you to put your resources inside, right? So, but think about from a design perspective. or just even an implementation perspective. Like, what does that look like when you're deploying resources into a Google global VPC and have to deal with like latency concerns, right? So you're probably not going to put in a red-blue deployment where they're in necessarily like, you know, different subnets or different subnets that are one in Tokyo and one in London or something like that. You know, that wouldn't make any sense, assuming that these two ever had to talk to each other or that they were serving the same customers or whatever, you know. But also think about the complexity, the lack of a complexity probably from a routing perspective of being able to have everything just kind of connected in the same VPC. But at the same time, the incredible complexity that that's going to add if you want to do any kind of segmentation or inspection between these workloads, right? And then it's actually flipping the script to go the opposite way to talk about like AWS versus, you know, Azure versus Google Cloud, where you have the opposite problem, where now you have routing concerns moving between VPCs, you know, and actually that the inspection doesn't get particularly easier in that case as well. It just becomes part of the routing, actually, is what ends up happening.
Yeah, for sure. Yeah,
right.
I think another point that's kind of continuing on this kind of differentiating philosophies between the cloud provider, these three major cloud providers as well, is the concept of the VPC or the virtual network router and how that participates in the conversation between the infrastructure that resides within the logical container. So, you know, like within AWS, there's the concept of a VPC router. You don't actually see a construct called VPC router. You don't actually, you know, configure something called VPC router. The way you do that is by defining route tables and assigning them to subnets, essentially, right? But you know, if you've ever worked on a router, you know what a route table is, right? It's a very, you know, definitive list of destination prefixes, next hops, etc. Right? So in this scenario, the next hop is typically, you know, it could be something outside the VPC, it could be something within the VPC, it could be an endpoint, like if there's a service that's deployed within that VPC that you need access to, etc. But one thing that is also fundamentally different is, you know, Azure and Google have the same construct, right? There is a router that exists within that VPC. It's a virtual construct, and the way you control that is defining those route tables. One thing that is unique that I'll call out specifically with AWS compared to the other major two is when that virtual router is involved in the conversation. So if we think like me logically as a network engineer my entire life, I'm like, oh, these two things are on the same subnet. They're going to talk directly to each other. Nothing needs to sit in between that conversation. That is true in AWS. You can't have direct peer-to-peer communication. It's like over a virtualized layer 2 thing we won't get into exactly on
There's
that.
no layer 2 in cloud.
Yeah, like we didn't even touch on that, But in Azure and GCP, that is not the case. The virtual router actually is involved in every single conversation. And if you think about that, then that can obviously cause issues when you didn't expect there to be issues, right? If you just assume things are on the same subnet, they should have, you know, full east-west capability to talk to each other. That's not always the case, right? So there's that concept that comes into play as well.
Yeah, for sure. I mean, and for completeness, just we'll speak briefly about OCI because the truth is a lot of what OCI does is very similar to the way, I don't know, it's kind of like from a routing perspective, it feels a little bit more like AWS. It is slightly different. The big difference to point out with OCI, and neither of us are OCI experts, by the way, just FYI.
Yeah, I was going to say, the reason we didn't really include OCI on this wasn't a diss to OCI. It's just the one we know the least.
Yeah, but I mean, I did some research on this because I wanted to include OCI because OCI is becoming a major player now that, you know, especially with like the AI workload stuff that they're doing and whatnot. Right. The big difference with OCI is that their concept of a VCN is really tied to these things called compartments, which doesn't really exist meaningfully in the other clouds, which is the idea of not just tenancy, but like secure, like administrative policy. So it's very, very tied into this idea of, if you want to connect if you want to connect anything together, there's like a whole compartmentalized policy that sits on top of all of that. So I'm not going to get into that. We could do a whole show probably on OCI when we become better at it, or we'll do is reach out to some of our friends at OCI and actually have that conversation. We know several. So, but again, as Chris said, not to diss, OCI. It's the one that both of us know the least because we both had the less. I think I had one customer that had OCI, and I had to learn enough about just to be dangerous.
Like 2 max, yeah.
So, but I think that will change, especially as OCI is coming up in the world now. They're getting definitely a lot more adoption. So, all right, let's talk a little bit now about under the philosophy, how the philosophy means the behavior is different, right? So, what that means is like, all right, so for example, going back to AWS, with manual AZ design, which we're talking about, like everything is very explicit in AWS. What that ends up meaning is that you, as a network, cloud network engineer, whatever the title is, that when you're building cloud networks, it means you have to be very, very specific. You have to be very granular, but also very predictive with it, which is honestly what, like I said, network engineers really like that because somebody told me this years ago, and I still think it's pretty good today. A network is like a dog, right? You want to train your dog. You don't want to let your dog run around rampant, just doing whatever it wants. You want the dog to do the tricks when you tell it. So that's very normal for us, right? But like with Azure, again, like Chris was saying, it's very much let us handle the complex parts, right? You build it and we'll handle all of the resiliency for you. Less control. It's easier HA, but you get less control over it. Now, in Azure, you actually can force objects to be deployed in certain AZs, but they actually recommend you don't do that because it breaks their HA automation, basically. Like then it's stuck to that HA, that AZ, and if that AZ goes down, it won't move, right? So again, different design philosophy. AWS is like that's how it is, and that's why you should design around it. And Microsoft is like, you don't need to design around it. We'll handle it. Does it end up being the case? I don't know. And then Google is just like global networking, like just put everything in the same network, and we will do all of the work for you. I think we've said many times that we feel like Google Cloud networking is much more developer focused and friendly because they don't really want you to necessarily care about it, honestly.
Unfortunately, but yeah.
So anyway, all right. So let's wrap up with some gotchas that you can run into, like in just with VPCs, even something as simple as just VPC design, the philosophies of the different cloud providers. If you don't, what's the word I'm looking for? If you don't kind of conform to the philosophy that they're using when they designed, like how they want you to design your cloud, basically, if you rage against that and try to do it, a lot of times it'll work, but it ends up being a lot more brittle. Like, when you're using third-party devices and you kind of use third-party devices to overcome some of the design choices. Sometimes you have to do that, right? Like if you can only have 500 routes in the route table and that's what they give you, but you need like 10,000, you have to do a third-party, something that can support it. But you should still design your third-party implementation with the design philosophy of that cloud in mind. Does that make sense? Hopefully it made sense.
No, yeah, I see what you mean. Yeah.
All right. So like, let me think about. So AWS, the big one is because you are very explicit about, and they expect you to be very explicit from a DR perspective and also from an HA resiliency perspective. They want you pinning resources to different availability zones, run kind of like an AB or a red blue. That leaves you as the network designer to deal with traffic that will cross availability zones. So what that means is that, like, sometimes that's a design philosophy, like you just need to be able to do that for resiliency purposes. Sometimes you're supposed to like build basically like application rails, if you will, where like you've got your X number of tiers of application, and the A tier or the A side should never talk to the B side, and vice versa, but depending on your application, depending on your use case, maybe that's not feasible. Right. And then let's not talk about, think about down the road, we might talk about firewalls and stuff where that's, that could be part of your resiliency strategy. If you have an actual firewall and that virtual machine dies, like what's going to happen to the traffic on that rail? Is that rail going to just die with it? Or is that, what happens? Do we cross availability zones? So the reason I bring this up is because cross AZ traffic and cross region traffic and just basically just transfer that leaves a data center essentially with AWS is money. Like they charge you. And now it's an infinitesimally small amount of money, but it adds up. It can add up very quickly.
If you're doing, synchronous replication between two data centers, that can eat up a lot of money very quick, right?
Yeah, and it has.
Right. So let's in that same vein of which I mentioned, like it's just a click of a button to make something, kind of multi-availability zone, multi-data center or multi-region. That all comes at a cost, right? They give you these, building blocks, but the building blocks are kind of no holds barred. You can build whatever you want, so you can kind of build your own noose if you're not careful, right? So yes. You've got to be very aware of that in the grand scheme of things, because I've said this many times, is that the thing that cloud networking brought to the table was this concept of a toll booth, right? It's like no matter where you're transferring data in and out of their data centers, you're paying the toll booth, whether it be 1 cent per gigabyte or 2 cents per gigabyte, what have you. It doesn't sound like much, but you haven't been paying that in your physical data center for the longest time, right? You've paid for a pipe, and you can either use all of the pipe or use none of the pipe, right? Whereas now it's like, hey, we built these pipes, and as you put oil through them, we're going to charge you for every gallon, right? So it's a different way to think about it.
Yep, absolutely. So that's, and to be clear, like every cloud provider has some version of this, but you definitely keenly feel it, what's the word I'm looking for? You have to really think about it in AWS versus like Azure, where, you don't even deploy in a specific availability zone and all of that, right? You're generally just deploying gear and trusting Microsoft to take care of it, but you're using availability sets to say, okay, Azure, this is my A rail, this is my B rail. They exist in the same AZ, maybe they're in the same damn data center, maybe they're the same rack. We don't know, right? But when you Azure do maintenance, consider that these two devices need to not be down at the same time, and the Azure automation will do that, right? So you're handing the keys. So the trade-off there is that you're handing the keys over to Azure, to automation. There's no person making this decision, right? Azure automation is deciding, oh, I need to reboot this rack, or maybe Azure's not deciding it at all. Maybe Godzilla steps on the data center and that AZ goes down, and now Microsoft is going to automatically move those workloads to another data center. But when you designed the applications, or maybe you didn't design them because you're a network engineer in this case, but the application may not be able to handle the latency that just happened from having to move to a second data center and connect to other stuff. So it gives you less granularity, a little bit more easy resiliency, but it also means that it's the classic Faustian bargain, right? Like you hand over the keys and you trust that, well, if it's not in my control, then hopefully they can take care of it.
So and just to be clear, AWS has this. They have kind of services and constructs that are available to let you fail over in the same scenario, but it's just not as implicit, right? You have to build it.
That's it.
So that's really the only minute difference. I just want to make sure it doesn't sound like we're saying AWS is less resilient or anything. Obviously, they're, like you said, they had first mover advantage, and they chose a path, and it was to let the customer build anything and absolutely everything, whereas Azure kind of came back with a different approach. But I will say there's also things that we see in terms of just the way the cloud providers are moving. It seems like and this is much more widespread than just the networking piece, but there are certainly differentiators that make the cloud providers look more appealing to certain, customers or, types of customers, verticals, et cetera. But like some of the services are kind of converging on how they bill for things. Because I think they'll see, like, if you're major cloud provider B and you see cloud provider A start charging for a certain thing, and people gripe about it, but they end up making record margins.
That's right.
Eventually cloud provider B is going to start charging for that as well, right? So it's like, just because things are free today or different today, that can drastically change. Like, just back to the concept of paying for cross AZ traffic or cross region traffic. I think, you can build this concept of a peering between these logical containers. So you can have a VNet peering or a VPC peering. Whereas, keep me honest here, but I think across VPC peering, as long as you stay within the AZ, you don't pay for that. Whereas That's Azure, right. If you use a VNet peering, they actually do charge for that, like on top of it. Yeah. So it's like there's nuance to everything.
Yeah. I mean, there's a lot more nuance than we could possibly get into in a in a podcast episode. But this is the point that we're making, right? Design philosophies, right? So AWS does exactly that. So VPC peering counts as data transfer only if the data crosses AZs, which is to say, like, again, take two different VPCs, put two different workloads in those VPCs, and maybe they need to talk. Well, if the workload in VPC A is deployed in subnet A, which is in AZ A, and then, VPC B is in subnet B, those are two different data centers. And so when those two workloads talk, even though it's entirely across AWS's backbone, it's still using their pipes and moving between crossing AZs. But,
right.
Whereas, if everything was in A, then that VPC peering would be completely free because it's actually not even leaving the same data center. It's in the same data center or discrete group of data centers as they call it, right? So
it's that's just hopping across the hypervisor.
Exactly. Yeah. So and this is the point, right? And then you have Google, where it's all global. It's all in the same. It's logically all in the same VPC, right? So from your perspective, it's all the same. But obviously, they're different. Between subnets really means between either geographical locations or at least data centers, or something like that. So, yeah. Why don't we wrap up real quick with some just misconceptions about what other people, what we really get wrong, what we really assume based on the names and kind of how we expect it to work, and then we'll wrap it up. You want to take this one?
Yeah, sure. So a couple ones that we hear a lot as far as misconceptions go is like people talk about, kind of within VPCs, like, a VPC or, subnet with it's kind of just like a VLAN. But kind of going back to that piece that I talked about before with the VPC or the virtual network router, that can very much not be the case. I would say that let's not talk about VLANs, man. In cloud, it's all layer 3. There's a couple scenarios where you need to identify VLANs, but that's only when you're building physical connectivity into a data center and you need to define a VLAN. But other than that, let's not talk about VLANs. Everything is segmented either at a virtual layer where you don't need a VLAN, or it's all layer 3 segmentation, right? So every provider, the concept of it being just like a VLAN, every provider breaks that in a different way. So this, like, if we want to, get down into the nuts and bolts, that's not really true. Also, this idea of like, I can put this in, if I want to change it later, that'll be super easy. And that's relatively true most of the time. However, there are certain things that become immutable per provider, right? So there's things that once you put them in, you cannot change them without completely deleting the construct, right? Now, we won't sit here and kind of list out each one of those things individually because we could be here all day. But, there's the cloud makes things easier, but like there's also dependencies built on their backends where they can't just, swap things out, right? You have to be aware of when that comes into play. So that's something you should also be very considerate of. Any additional ones you can think of, Tim?
Well, I mean, just speaking about the VPCs themselves, right? Like a VPC is immutable in that once you create it and you assign a CIDR to it, you can add new CIDRs, but you can't like change the CIDR that was assigned. You're done. That's every, and if you want to change the CIDR of a VPC and not just add a second one, but like fundamentally change it, you have to destroy every resource that is in that VPC and then delete the VPC, and then you can recreate it with a new site. And if you think about it, like if you deployed a whole application stack in that VPC, like that's not a small change, right? If you've designed it right, then hopefully there's another VPC, or you just stand up another VPC, and replicate the application. That's really more what we're talking about. Is truthfully, you're gonna in cloud, you're not going to have this downtime where you're going to destroy something and then rebuild it, right? You're just going to build another one. Remember I said you got VPCs where you can have the same CIDRs and all this other stuff, but you're going to build another one and then you're going to tear that one down, right? And you're going to move all your workloads and everything over. But the point is, I know that cloud is agile, but it's not immutable, or it is very immutable. There are things, especially with VPCs, that basic construct is an immutable construct.
Maybe if you're a very important customer and you call support, there's probably some strings they can pull, but you don't want that to be part of your regular workflow. That would just be, I don't know how if you guys like spending time on the phone. I don't, so I wouldn't make that a habit.
Yep. So if you guys, we'll go ahead and wrap up. If our listeners enjoyed this, this type of format, or if we hit too high, we hit too low, we didn't hit the right things, we would love some feedback, because we like the idea of kind of going into some of this, especially like how it's different between providers, and also how you as a network designer are going to have to think about the fact that it's different and what you're going to build with it and what it lets you do or doesn't let you do. If we're hitting the right notes, let us know and we'll do more like this.
Yeah, we know we have, listeners that everyone's at a different stage in their career, right? Some people are absolute beginners, some people are, very seasoned vets, right? And then the same scenario applies to cloud, right? Some people are just getting started with cloud. Some people have like only been doing cloud for the last, 5-10 years, something like that, right? So it's like we want to kind of go over some of the base layer concepts, and maybe we'll turn this into a series or something like that. And we'll talk about, we touched on the most basic thing here, which is VPC, but we can start talking about, inter VPC or inter VNet networking, services like transit gateway, cloud WAN, virtual WAN, et cetera. So I think we'll probably expand into some of that and talk about some of the security concepts and, draw analogs to traditional networking there, and talk about network segmentation, et cetera. So that's where we're headed, or where we're thinking we're going to head. So we would love some feedback. So please reach out, email, Twitter, X, Blue Sky, LinkedIn, whatever. Just send us a PM. Let us know.
Yeah, appreciate it. Okay, let's go ahead and wrap up. Speaking of, Chris already gave all the list of places we want you to follow us, and and speaking of
YouTube as well. You can
YouTube, of course.
Can comment on YouTube if you want.
Yep, please feel free. It'd be nice. You usually just get the spam ones.
No Nigerian princes, please.
Yeah. All right, we'll wrap it here, and we will see you guys in the next episode.